All right, so today we're going to look at the differences for the different calculations that are involved in scientific notation, just kind of reviewing some of the math, and then also getting into a little bit more depth of some of the equations and or math that can be done to help us understand some of the accuracy and precision that can be done after we collect all of our data. One of the easiest ways to enter many numbers into scientific notation is using the EE button in the calculator that you use. Sometimes it might be an EXP button. I've even seen some buttons on calculators actually have it written as times 10 to an n value. We do need to be careful about that because sometimes they are ones that also use an equation or a logarithm, something that we're not going to use. And so we do need to be very careful about that. When entering these in, it's important that when we key them in, that we key them in correctly. Say if I wanted to write 200 into my calculator, if I wanted to write 200 or 2.00 times 10 to the 5th into my calculator, I would not write it in that way. I would key in 2.00. I would, a lot of times it will end up require us to hit the second, and then it'll be the EE button. And a lot of times on a calculator, what happens is that it will show up as an E, and then I would hit in the 5 and it automatically goes up there. Or I've even seen some calculators that will put it in as times 10, and then you put it up there. So what calculator you use, it will depend, and that's why getting a calculator for yourself that you're going to use consistently so that you know how to put it in, because every calculator is just a little bit different. When multiplying and dividing these things, especially when it comes to sig figs, we need to use the one with the fewest number of decimals, or the fewest number of significant digits. We have to be able to count that. And so in multiplying and dividing, why we talk about this one first, because it's actually one of the odd ones, is that it's actually easier than the adding or subtracting. So the first example, we have 6.834. Well, that has 4 significant digits. Divide that by 2, which 2.0 actually only has 2 significant digits. Even though the division, if we put it in our calculator, would give us this, we need to round that to 3.0. In case you would say you would be rounding down. The 1.01 times 1, well, you would actually get, and everyone knows that the number times 1 is just going to be that number. Well, because of rules of rounding and significant digits, we actually need to round it to the actual answer of just 1. The biggest thing to understand is multiplying and dividing, which we do a lot in physics, is the one with the least number of significant digits total. In addition and subtraction, the results have to have the one with the decimal point. And this gets to be a little confusing because a decimal point is involved in. And so it's the quantity with the fewest sig figs after the decimal point. So that's your limiting factor. We don't do a lot of adding and subtracting, and if we do some adding and subtracting, we will tend to use multiplying and dividing. So we don't spend a lot of time on this one because the number of times that we're actually going to have to do this is much, much, much less. But what does that look like? Well, we have some larger numbers here that might require some addition and subtraction. And so we have to make sure and add up, always do our rounding at the end, because sometimes you never know what could be done. And so we get our answer, and then we round to the one with the least number of significant digits. In this case, because there is no decimal. Now, in this other example, we actually have decimals, and so we need to pay attention to that. And now sometimes it also works out where the subtraction or the addition actually ends up working itself out so that you actually do report the number with the least number of significant digits after the decimal place. In this case, we would have this example here only has 2. We don't round it here because if I did, I would actually be missing the 6 when it comes to my significant digits. So it is important that we always round after all the math is done. Now, decimal notation is the preferred method that we use instead of fractions, because then it takes a lot of the harder math out of it. And a lot of people don't like doing the math with fractions, especially when it comes to adding or subtracting or even multiplying and dividing with fractions. I've always found that to be somewhat of an issue with many students. So it's a lot easier, and that's what we do in science. We do try to make our lives easier, and that is using decimal notation. Now, there are some rules for rounding. Most of them you actually already know. The first two, for sure, you usually know, and that is the dropping the number with the less than 5, leaving the preceding number unchanged. For an example, 1.43, if I needed to round that to 2 significant digits, the 1 and the 4 need to stay. I would be dropping the 3, and therefore, because it's less than 5, my answer would be 1.4. That changes things, and we a lot of times just called this rounding down. If the first number to be dropped is greater than 5, or 5 followed by non-zeros, we increase the number by 1. So an example of that would be 1.4 and let's say 6. If I needed 2 significant digits, again, my 1 and my 4 are my significant digits. My number to be dropped then is my 6. I then have to round and increase my preceding number, my 4, up by 1 to make it 1.5, meaning I rounded up. Now, 3 is an example of a rule that you will most likely never very rarely have a chance of actually seeing. It's usually used for numbers when you say have 1.5 and this. What do you do? Or even 1.45 with a lot of zeros after the fact. What do you do? Well, that's where this comes into play, whereas you increase the preceding number if it is odd, and if it's even, you leave it unchanged. And that's, again, one of those odd ones that we have, but very rarely will ever come in need. The range is a calculation that is the difference between the largest and the smallest. Range helps us try and find precision. And so with precision, it's a precision calculation. A small range means that your largest and your smallest are very close together. And so therefore we have a small area that all of our data points are in. Hence, good precision. The mean or average is a calculation that is done a lot of times, and a lot of times people just inherently know you add up all the answers that you have and then divide by the total number. Well, that's true, but it actually does have an equation. Now, I usually like to put these in an Excel spreadsheet, as it does make our lives a lot easier, making the technology work for us. And we'll go through that on how that looks like and what we do for that in class as we need it to just, again, make our lives easier and make the technology that we have work for us. The median is a value, one of the m's that we tend to solve for, and that is the middle value. When we solve for the middle value, a lot of times you have to go through the process of canceling out each side and trying to find where your middle is. Sometimes it's just counting how many total and then going from there. But sometimes, again, just going back and forth to find that our middle value in this case would be 5. Sometimes when there's not a middle value, when it's there, you have to add the 2 and then divide by how many. That will give you your median. And that's just kind of finding a big data set. It's just one of the statistical analysis, or I call them the 3s, mean, median, and mode that you would solve for. Now, average deviation is an estimate of how far off things are from the actual from the average value, meaning how close are your numbers, but also kind of like estimating some errors. And it's there for that, and again, for some precision, and also then allows you to start bringing into this idea of actual values and the average, and that means you're going to start actually looking at your accuracy. If you have really bad precision, your average deviation is there. Now, the other route that one could take would be called standard deviation. We don't use that one because of just how often we need standard deviation for a class such as this. So we will tend to use just average deviation. Standard deviation is a more accurate method, although average, though, is a little bit easier. And so what we do with that is we do find our average, and then we add it together, and that's how we do that. And we have our average, and that's what that looks like, our average value. And so we have that in each one of these absolute values that we have here. And then we add it, and then we divide by the total number. And that's going to give us just an idea of what we do with that. And so it's not great, it's better than nothing, and it does tell us some information, and that's important. And that's going to be, it's because of the ease of calculating on what makes that nice. These are just a few of the statistical analysis that we can do. There are more, and we will talk about some of those as we need them. But these are the big ones that I think are important to at least been exposed to.